Okay, I want to start off talking about what happens when you drop something. The gravitational force pulls something, an object with mass, downwards. All right, that is the gravitational force. This is going to be all we're really talking about with gravitational force right now. It pulls it down towards the surface of the earth. And this applies to the surface of the earth, because as you get further away, different things happen when you get really far away. But as far as we're concerned, gravitational field pulls that down to the surface of the earth, the gravitational force. Anyway, what happens is this accelerates it. This accelerates your object, and that acceleration we're going to call acceleration. I'm going to put a little g, due to gravity. That's what's making this fall, an object with mass, fall faster as it gets closer to the surface of the earth. So anyway, it should look like something like this. See how this is kind of like stop motion, or they've kind of taken a picture to where this looks like a ticker timer. That's on purpose. So when you drop something, you start off with, like, let's say that they took a picture of this, or it was like a strobe light or something. They took a picture of this at even intervals of time. So the first interval of time will be really close together, and then gradually it starts getting further and further apart. What that means is it's speeding up as it goes along. And if it's speeding up as time increases, then you can say that it's accelerating. And so your ticker timer thing, and it probably won't have because you have some other things going on. Well, that's just messed up. But anyway, your ticker timer tape should look something like this ball dropping in this little cartoon thing. All right. Okay, so let me kind of show you how to do this. This would be like the ticker timer thing for this guy. Let's see, so red pen. Let me try something really quickly. There, I want to make sure I can get my ruler on screen. Okay, this might be a little bit tricky, but anyway, let's look at what we're going to do is let's look at what actually happened. This is on this would be, this dot is where your time is equal to 0. Now, I want to point something out. Since you're falling down, and let's set our frame of reference to where up is positive. Okay, and here we'll set this as the y direction, up and down, and then I'm going to set this as the x direction. See, I want to know what's the direction, so I'm putting hats on these. Okay, and then x positive, or positive x. This would give me an indication of what I'm looking at. Okay, so, and this thing is falling down, correct? So that means that this is up and this is down. This is going to be your initial vertical position. I'm using y because this means position. I'm not putting a hat, it means position. So your initial position is going to be like right up here. So it's going to have a number. And your final vertical position is going to be right here, and that's the ground, and that's going to be 0. That's really important that you know that. So this dot is, you know the measurement for this. This dot, y, right here, equals 0. So it says time equals 0 and y equals 0. That's supposed to be y hat. That really looks weird. Okay, so this is how you would measure it. You would measure everything you're going to measure is going to be up from this. The way I was telling people in class is, okay, picture you fall, okay, pause, and then rewind. And you're measuring in rewind mode kind of thing. So I'm going to take my ruler, and let's look at it. I'm going to start from this one, and I'm going to measure to this. And that looks like that would be, oh, I would say 3.8 centimeters. And that's about the precision I would measure to. So I'm going to say this one is at y equals, you don't have to write y equals every time, I'm just doing that, 3.8 centimeters. Okay. I mean, obviously this isn't a real person falling off of a cliff. None of this is to scale. This is just all for an example for you. Yours would be, but mine's not. Okay, so let me get the ruler again. Okay, 7 centimeters. Okay. 7 centimeters. I've kind of lost my y equals. I want to get through with this. Okay, next one. I'm saying, let's see, right at the edge here. I'm saying 9.4. So that's 9 centimeters and 4 what's? 4 millimeters. 9 centimeters, okay. Okay, I think 11.3. I'm only going with what I can measure. I'm not putting like 11.35. I'm just going to put 11 because I can't measure that far. 11.3 centimeters. Where'd my ruler go? Okay. Okay, 12.5. That's a 5. That's a centimeter. And you know what I'm going to do real quick? I'm going to switch my time to blue because this is confusing. Okay. And then let me find out my final, or my initial position. I'm going to say on this one, I'm going with 13.3. Okay. So back to red, and I'm going to say that my initial position was 13, so I didn't, if this were real, I didn't drop it very far, 13.3 centimeters. Okay, and that is how, and let's also just kind of say that you recorded your total time. This is the stuff that should kind of be in your notebook. Okay, let's go with time total. Just put total, I'll abbreviate it. Was, let me see. And let's say that my total time was 1.63 seconds. I'll kind of have this written in my notebook. All right, so this is kind of like what you should have before you get started, or I guess some of you worked as you kind of did this, but this is the information that you should have going into putting stuff into the spreadsheet.